Alright, so in this question here we're going to find the quotient of two functions. Let's give it a look. So we're told that f of x is x squared plus 5x plus 6 and g of x is x squared minus 9. So what that means is that y equals x squared plus 5x plus 6 over x squared minus 9. That's because the question's asking us to find f divided by g, which is just that. Okay, so what we can do next here is we can actually simplify this down a little bit into y equals x plus 3, x plus 2, divided by x plus 3, x minus 3. That's just basic factoring. Two numbers multiply to 6 and add to 5, 3 and 2. Two numbers that, and the second one here is the difference of squares. X squared minus 9 just simply turns into x plus 3, x minus 3. So at this point here we can actually cancel out the x plus 3's, leaving us with the function y equals x plus 2 divided by x minus 3, with the restriction that x cannot equal negative 3. So that there is your equation. Maybe you don't have to have brackets on both. It kind of brings me to something that I'll just mention briefly. Whenever you see an equation where it's like x plus 2 over x minus 3, that means bracket x plus 2, bracket divided by bracket x minus 3. Bracket, in other words, x plus 2 divided by x minus 3. It's something that's kind of just written and becomes intuitive after a while, but I don't think that anybody ever really talks about that at any level of math, so it's just something that I find a little bit interesting and bears mentioning. Alright, so at this point here, we know how to graph this. We learned this back in section 3, so let's give it a look. It's going to have a horizontal asymptote at the ratio of the leading coefficients, because they're the same degree, so it's going to have a horizontal asymptote at y equals 1. It's going to have a vertical asymptote at the restriction here of 3, so x equals 3. And lastly, it's going to have a hole at x equals negative 3. Now we're going to have to figure out what that y value is when we get to the range component, but we'll worry about that when we get there. Lastly, we're going to need to figure out what the x-intercept and the y-intercepts are to give us a little bit more of an idea of what the graph's going to end up looking like. So the x-intercept here would be 0 equals, setting y to 0 to find the x-intercept, x plus 2 times x minus 3. At this point here, we're just simply bringing this x minus 3 up, which becomes x minus 3 times 0 equals x plus 2, which gives us 0 equals x plus 2, which gives us that x equals negative 2. And then the y-intercept here would be when x equals 0, so y equals 0 plus 2 over 0 minus 3, so it equals negative 2 over 3. Like so. Now we're ready to graph this. We have our horizontal asymptote, we have our vertical asymptote, and we know where the hole occurs. So I'm going to pick my x and y axis accordingly. I'm going to go by units of 1 here on my x-axis, and I will go by units of 1 on my y. I'll stretch it out just a little bit more than my x. Like so. Alright, so I'm going to draw my I'll plot my points first actually. I have negative 2 on my x and negative 2 over 3 on my y. And then I'm going to put in my asymptotes here, which occur at, so I have a different color marker. I do. So I have my asymptotes at x equals 3, which will be right here, and at y equals 1, which would be right here, like so. So lastly, if you can recall, the way that these rational functions occur is that they're always going to be in opposite quadrants. So here, this one's going to go like that. It's always going to approach asymptote to asymptote. So we don't need to really explore the end behaviors. We can kind of just take it from there. And this is a basic sketch. Lastly, we've got to state the domain and range. So the domain here is going to be the intersection of the two with the exception that it's never allowed to equal any of the values for x that would give us y equals 0. So in other words, it's not allowed to equal the roots of this. So x is not allowed to equal plus minus 3. That's just the rule for quotient functions. Plus the overlap, and in this case here, there is no overlap, so we don't have to really worry about that. So that's all there is to that. XER, x cannot equal, plus minus 3. Then for the range here, the range is going to be that y cannot be equal to, there's going to be two values here. And I just realized that I'm actually missing something here. I'm supposed to have a hole at -3. I forgot to plot that. So that would be right here. So that y value there would be what y would be when x is -3. So if we plug -3 into this function here, I'd have -3 plus 2, which is -1, divided by -3 minus 3, which is it's -6. So I have -1 over -6, it's 1 over 6. So y cannot be 1 over 6, or it cannot be that asymptote value of 1. And that's all there is to it. So when I say that's all there is to it, it's a reasonably difficult question, but it's something that you'd really need to go back and look at section 3.2 to really grasp it. But the key idea, the key takeaway here is that when we're doing a quotient, we just divide them. And the domain is the overlap, with the exception that whatever is the second thing being divided, the denominator, we also have the restrictions for whatever x values would give us a y value of 0. So in other words, the roots of the denominator are also restrictions. All right, thanks.